Welcome back. This is the day Lord's made. Let us rejoice and be glad in it. In this video, I'm going to talk about two different things. They're the same thing. They're related. Two different things, power and the kilowatt hour. All right. So power, when it comes to electricity, is based off of two things. How much motivation the electrons have as they come and how many come. So the more motivated and the more electrons that show up, the more power you get. So our equation is power equals current times, this little triangle means change in voltage. All right, so again, the idea is work is done by electrons moving, how motivated they are. So more electrons, more work. More motivation, more work. So for electricity and for anything, we talk about power, we measure it in watts. 1 watt equals 1 joule of energy done per second. All right, now for some of the, like maybe the A-level questions, you might need to actually keep an eye on the actual voltage being used, because if it's in series, you want to get to use the actual voltage allowed. But if I don't give anything else, you can just assume you get the full voltage. All right, so for example, in America, if I don't give you the voltage, you should assume we're hooked up to an American outlet at 120 volts. So sample questions, how much power does a device that draws 5 amps into it produce? So if we have 5 amps of current coming into some device at your house, how much power is being used by it? All right, so I didn't give you the power. In America, I didn't give you the voltage. In America, your outlet provides 120 volts. All right, power is equal to how much current, which is how many electrons are showing up in amps, times how much voltage they get, how much motivation they have. So they're 120 volts motivated, there's 5 amps coming in, that's gonna be 600 watts being done. So again, it's no different than getting ready for like some party. The party gets ready faster if you're more motivated and more people help. Or if you're part of student council and you want people to get ready for some big thing going on. So the more people you have volunteering, the faster it gets done. The more motivated they are, the faster it gets done. All right, so power is the same for the electrons. The more electrons and the more motivated, the more work that gets done. Another question for us, let's say you plug your hairdryer in and it's an 1800 watt device. So that means if it's an 1800 watt device, that means per second it's using 1800 joules of energy. How much current will be going into the hairdryer? All right, well, to find the current, we got to rearrange the equation because power is equal to voltage times current. So to rearrange for the current, we got to divide power by the current. So power divided by current gets us voltage, 1800 divided by 120, because again, it doesn't say 120 volts, but we can assume it's here in America. That's gonna be 15 amps. All right, again, so from a previous topic too, circuit breakers are typically rated at 20 to 30 amps. So that's why you can't plug 2 hair dryers into the same outlet, otherwise you'll probably blow the circuit. All right, so power is relatively straightforward here for us. Power is just work per time. In the electrical world, it's equal to the motivation, which is the voltage, times the amount that show up, which is the current. So voltage times current is power. Now, the next thing for us is the kilowatt hour, which is actually a unit of energy used, because most people use a lot of energy every single day. So even like a 60 watt light bulb is going to use a lot of energy. So quick math says, what if you have a 60 watt light bulb on for 1 minute? How much energy? Well, 60 minutes or 1 minute, 60 seconds, 60 times 60, that's going to be 3,600 joules of energy. Well, what if you leave that thing on all day? So 60 joules per second times 60 seconds in a minute times 60 minutes an hour times 24. That is going to be roughly 5 million joules of energy used by that light bulb. So the kilowatt hour is so that people can keep track of how much energy they've used in a meaningful manner when the power company charges you. So when you get your bill every month, it's going to charge you not by the joule, because that's way too many, because again, a light bulb being used would use 5 million a day, and your electric bill would be like, I don't know, this number's so big, I have no idea. You know, we use the kilowatt hour. A kilowatt hour, again, as for consumers, is kilowatts times hours equals how many kilowatt hours you're using. 1 kilowatt hour then is if you had a 1 kilowatt device, a 1,000 watt device run for 1 hour. So in terms of joules, it's 3.6 million joules of energy. But the kilowatt hour is straightforward. You know, we charge you by what's the rating of the device, what's the kilowatt rating of the device, times the amount of hours you use it for. Then you get the kilowatt hour. All right. So for example, if we have a 100 watt light bulb run for 10 hours, how many kilowatt hours would that be? So what do we got to do? We got to turn that wattage into kilowatts. All right, so to take watts into kilowatts, we divide by 1,000. So 100 watts divided by 1,000 equals 0.1 kilowatts. So kilowatt hours is just how many kilowatts does the device use times how many hours run. So we had a 0.1 kilowatt device run for 10 hours. That'd be 1 kilowatt hour. All right, it's straightforward. Just take the kilowatts times the hours. Again, the reason I don't use watts is because, again, we keep the number small. All right, in order to keep the number small, we use the kilowatt, even though most of your devices at your house are under a kilowatt. Again, the only exceptions for that pretty much are your stove and your dryer, and if you have an electric furnace. All right, but most of your things at your house could be actually under 1,000. But because we want consumers to have a number that's meaningful to them and small enough to use, we use the kilowatt hour. All right, and the most important question is how much is it going to cost me to play my computer, you know, or for you if you're playing your computer. So let's say I play my computer, which is a 600 watt device, for 20 hours. I want to do that straight. That's a long time. How much will it cost me to love to play it if it costs X amount per kilowatt hour? Now, the cost of the kilowatt hour changes based on where you live. It can range anywhere from 2 cents to 25 cents a kilowatt hour, depending on what region of the United States you're living in. But here in Omaha, it's 10 cents to 11 cents, depending on how many you use. So anyway, so to find out how much it's going to cost me, we just got to find out how many kilowatt hours am I using and then charge myself for every kilowatt hour. All right. So we're going to take that computer, 600 watts, turn it into kilowatts. 600 divided by 1,000. My computer is a 0.6 kilowatt device. I played it for 20 hours. So kilowatt hours is just the kilowatts, which is 0.6 times the hours, which is 20. That's going to be 12 kilowatt hours of entertainment I got right there. All right. So if each kilowatt hour costs me 10 cents, and I'm using 12 of them, we're going to just take 12 times 10 cents. That's going to be $1.20. All right. That's reasonably cheap entertainment. So in any case, to find the kilowatt hours and to find how much it costs you, you just take the wattage of the device divided by 1,000, multiply by the hours you're using it, and then charge it by how much it costs. All right, again, this is probably the most important thing for you to remember as you get older, because eventually you're going to pay the bill. All right, eventually you're going to be in charge of paying your electrical costs. Let's do one more question here for us. Let's calculate your, how about a dryer machine? Your dryer is probably a 3,000 watt device. Let's say you run it for a Saturday. All right. Now say you do 7 loads. And we'll keep the cost same. So basically this is okay, we're gonna do my laundry today. How much is it gonna cost me to dry my clothes? So option 1, you put it outside, the sun dries it for free. Option 2, you can turn the dryer machine on and it'll dry it for you. All right, so what do we gotta do? We gotta first turn that wattage into kilowatts. So 3,000 watts divided by 1,000, that is a 3 kilowatt device. How many hours are you using for? 7 hours, so 3 kilowatts times 7 hours equals 21 kilowatt hours. If it's in Omaha, times that by 10 cents. And that's gonna cost you for the day, $2.10. That would be the cost for you to run your dryer 7 loads on a Saturday. All right, God's peace. Have a great day.